Hi guys, I'd like to thank Zev for presenting my video to the ETE module group on the signal towers that I built. One of the questions that came up was, could you use a Marklin M83 to switch the lights? And the obvious answer is, yes you can. But there are two buts to this question. One, you need to be careful with the circuit. You cannot use the type of circuit I described in the first video. For the M83s, you need a circuit with common anodes for each red-green pair, and the M83 will switch the ground connection. The second but is, do you want to spend that sort of money the M83 solution requires? I've started this video with a rundown of what I have built and how much it cost me, and compared it to using a Marklin M83 operating in mode 2 with 8 addresses. Here you can see that we've got a total of 46 LEDs to switch on and off in the 3 towers. Basically that means we need something like 6 Marklin M83s or 3 of my Arduino setups. As an aside, the Uno has 20 switchable pins, so it is possible to switch 40 LEDs with one Uno circuit. I've used 3 Unos because I did not want to string long runs of wire around my layout. My Arduino setups cost approximately $11.50 each, while the Marklin M83s will cost somewhere around $50 each. So a full set for the 3 signal towers would be something like $300 versus $34. Certainly I would not want to have started building 3 signal towers if I was going to spend $300 on Marklin M83s. It is true there's work in putting together the Arduinos, but it's work I enjoy and it certainly saves money. I found I had some pictures that I did not use in the original video, and I've thus made some bonus footage of the points I did not cover in detail in the first video. In this picture we're looking at the PC boards that carry the resistors for each light, and on the right hand side are the resistors for the 3 building lights, one on the top floor, one on the first floor, and one on the porch over the door. On the left hand side there are 14 resistors soldered on the board, and each row, left and right, represents where one wire will come in for the red or green lights. Here I'm showing where I've soldered in the first wire. This is now just tedious work ensuring the wires do not get mixed up. Here is the first check of all the lights that they are functional. At the top of this picture, all the common wires are visible coming off the center of the circuit between each LED. This common is switched by the Arduino to either plus 5 volts or ground to switch the left or right light on. The top wires as I purchased them and as you see them are all grey, but as I deal with each set, I solder one ESU colored wire extension for each light bank. I have a table made up so that I know that the first wire is purple and the second wire is blue and the third wire is black, etc., etc. Moving on to working on the assembly and getting the lights into the control panel. Here I'm showing how I've cut the control panel open at approximately 45 degrees. The piece of plywood with the 7 sets of holes on it is going to form the top panel, and the light tubes will come through these holes when it is glued at the angle of the panel top. Here we see the panel covered with the Auhagen decal. We're now looking at the assembly of the fiber optic pipes. You can see that I've put dots of foam glue to hold the 14 pipes to the piece of plywood. I flip it to the other side and slide on the second plywood board. In this picture I'm showing you 2 assemblies ready for the foam glue to be placed between the 2 pieces of plywood. Here we finished the rough assembly. The one on the left I have not yet cut the tubes, and the one on the right I've cut the tubes down. The next step is to sand the base nice and flush. Here we've sanded it flat and flush and painted one bank green and the other bank red. Now for some more testing, and we're looking at light leakage. You can see the black JB Weld putty that I've put around the edge of the sandwich block to shut off any light escaping around the sides. but you can see that there is still light escaping around the wires at the bottom. In this picture I put some JB Weld epoxy as opposed to putty on the wires. I consider this a final assembly in my lifetime, and it's not to be taken apart again. Note at the top of the picture you can very faintly see some of the lights glowing red and green from the paint markings we put on the bottom of the board. Then the assembly is pushed in and glued in place from the bottom. I then insert the white top board over each pipe, get them all through, and then put a little bit of foam glue on the top of these pipes because I'm going to lift this board up, pour glue in underneath it. That way everything is locked in place. You can see also that I put liquid insulation on all my solder joints because this piece will be placed in the body of the signal tower. Here we're looking at the top floor light. On the first model I tried to run the wires through the area where the signalmen are, from the top to the bottom, but it was not really satisfactory. For the second two I decided to take the wires outside at the roof level. They are very small and they're almost translucent, and they'll run down the drain pipe and disappear back inside the model on the first floor level. A couple of tips on assembling the signalmen's working area. After working at this with different models, I found that the best way is to pre-assemble and glue these brown pieces to the white windows before you try and assemble the walls. I also added a switchboard diagram in each of the signal towers. I made the picture from my train controller switchboard, showing all the points as they are being controlled by this particular signal tower. You can see here that I have got the two men glued in place, and the key thing is to ensure that the window will still fit. The window is basically a rectangle of clear plastic that slips in here, and you need to make sure this guy's arm sticking forward clears the window. The final note on this step is also learned by experience. The assembly sequence of the two small walls on the left and right shown here in this magenta color, I found it best to put these walls in last on this step of the construction. And up here you can see the red and green panel lights. So there you have it, a fun project. Thanks very much.